Good morning to everybody. Today we shall start the session number 9, properties of composite functions. So, ಇದರಲ್ಲಿ theorem number 1, composition of bijective function is bijective. Its proof is what? Let f maps A to B and g maps B to C be two bijective functions. We shall show that the composition G compose F maps A to C is bijective ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. So first we shall show that G compose F is injective. Consider G compose F of x1 is equals to G compose of x2. It implies that G into bracket F of into bracket x1 bracket complete that is equals to G into bracket F of into bracket x2 bracket complete. So it implies that f of x1 is equals to f of x2 since G is what? Injective ಅಂದಂಗೆ. ಇದರ ಅರ್ಥ it implies that x1 is equals to x2. It means f is what? Injective. So therefore G compose f is injective. Call it as equation number 1. And secondly we shall show that G compose f is surjective ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Let small c element c is belongs to the set C be arbitrary. By data G is surjective. Thus there exists B is element of set B such that G of B is equals to C. Again by data F is bijective. Thus there exists A is element of set A such that F of A is equals to what? B. Therefore G compose of F of A is equals to G of F of A. It implies that G of B is equals to what? C ಅನ್ನಂಗೆ. So it implies that for every C is an element of set C, there exists an element A is belongs to A such that G compose F of A is equals to what? C. Therefore G compose F is surjective. Call it as equation number 2. From equation number 1 and 2, it follows that function G compose F is what? Bijective. So hence the theorem. And theorem number 2, if F maps A to B and G maps B to C be two bijective functions, then G compose F it bracket inverse exists and G compose F inverse is equals to F inverse composition of G inverse. So its proof is by given or data the function f and g are the bijective functions. Thus the composition of G compose f is also bijection. It implies that inverse functions f inverse and G inverse and G compose f bracket inverse is also exist and also it is what? Bijective. Further these functions are f inverse maps B to A, comma G inverse maps C to B and G compose F bracket inverse maps C to A. Further as the function f inverse and G inverse are bijective functions, the composition f inverse compose G inverse there exist and also they are bijective. Thus the function f inverse compose G inverse maps C to A is what? Bijective. And let G is belongs to set C be arbitrary. Now G inverse of Z is equals to Y. It implies that G of Y is equals to Z where Y is also element of P. Now F inverse of Y is equals to X. F of X is equals to Y where X is element of A. Consider F inverse compose G inverse bracket close of Z is equals to F inverse into bracket G inverse of Z bracket close. This is equals to F inverse of Y is equals to X. Call it as equation number 1. Again F of X is equals to Y and G of Y is equals to Z. It implies that G compose F of X is equals to G of F of X that is equals to G of Y is equals to Z. It implies that G compose F bracket inverse of Z is equals to what? X. Call it as equation number 2. From equation number 1 and 2, it follows that for every Z is element of set C. So G compose F inverse of Z is equals to F inverse composition of G inverse bracket close of Z. Hence, G compose F inverse is equals to F inverse composition of G inverse. So, hence the theorem. And next, theorem number 3. If F maps A to B is 1, 1 and onto, then F inverse maps B to A is also 1, 1 and onto ಅಂತ prove ಮಾಡಬೇಕು. That is what theorem number 3. Now its proof. Let x1 and x2 be any two different elements of set A whose images are the y1 and y2 such that f of x1 is equals to y1 and f of x2 is equals to y2. Call it as equation number 1. If f inverse is the inverse of f, then f inverse of y1 is equals to x1. F inverse of y2 is equals to x2. Call it as equation number 2. Since f is 1, 1, so x1 is not equals to x2. It means they both are different. If and only if f of x1 is not equals to f of x2, their functions also not equal. From equation number 1 and 2, equation number 1 ಏನದ f of x1 is equals to y1, f of x2 is equals to y2. Equation number 1, f inverse of y1 is equals to x1, f inverse of y2 is equals to x2. Call it as equation number 2 is there. Therefore, from 1 and 2 we have, or that is f inverse of y1 is not equals to f inverse of y2 if and only if y1 is not equals to y2. Call it as equation number 3. Thus f inverse is 1, 1 since f is onto. Therefore all the different elements of B are free image of different elements of A. Therefore all different elements of A are f inverse image of different elements of B. So it implies that f inverse is onto. Call it as equation number 4. Combining 3 and 4, we have f inverse is 1, 1 and also. Hence the theorem f inverse is 1, 1 and onto. So on this these theorems they are proved. It means you will understand the composition function, inverse function and their respect to both 1, 1 and onto. It means you know the well defined or well definitions about what 1, 1 and onto functions are, injective and surjective functions. Then both satisfy, that is bijective functions. Their applications will be seen in that theorem number 1, 2, 3. Okay. So a small objective type question is there. If f is a real valued function, find the domain of the following functions ಅಂತ ಕೇಳ್ತಾರೆ. ಫಸ್ಟ್ ಒನ್ ಏನಂದರೆ f of x is equals to x divided by x square minus 5x plus 6. So its domain of f is becomes what? R minus the set 2, 3. And f of x is equals to square root of 9 minus x square. ಅಂದರೆ ಇದರ domain of f is becomes what? Minus 3 and plus 3. Then third one is what? F of x is equals to x divided by 1 plus x square ಅಂದರೆ its domain of f is becomes what? Their respect to R ಅನ್ನಂಗೆ. So the second one, find the range of the following real functions of f of x is equals to 1 upon x minus 9 ಅಂತಂದರೆ its range is what? F is equals to R minus singleton 0. So second one, f of x is equals to x square ಅಂದರೆ its range is f is equals to 0 to infinity. It is a semi open interval. And similarly f of x is equals to x divided by 1 minus x ಅಂತಂದರೆ its range of f is equals to r minus in singleton set minus 1. So these are the total session number 9 ಏನಿರ್ತದೆ ಆ session number 9ನಲ್ಲಿ 1 to 3 theorems and 2 objective questions are over. That is what properties of composite functions. So that dear students, you will observe and also understand each by one steps, then you are familiar. So then that theorems are very useful and also easy to solving. So this is what session number 9 over. If any doubts, then previous definitions you know well.